Question?
Yes. If the program was up higher, closer to where CE becomes CE, would this not work?
That's a great question. Are there some conditions where this doesn't work? For example, if the CD byte somehow rolled over, I guess, into CE. And you're right, there's actually some cases where this is not going to work. On the project, if you get unlucky, you might run into one of those cases. And we'll talk about how you can fix it on the project. So I'll leave that as an exercise to you, or you can ask later. But it's possible that some configurations of addresses will not work. That's a good question. Any other ones? OK. Oh, yeah, go for it. Sorry.
Why are you adding 16 bit? Add 16 to ESP.
Oh, add 16 to ESP. So it's really not the most important thing here. But if you go back to the steps of the function call, this is step 11. It's the step where I remove the arguments from the stack. So here, this ... I pushed 4 arguments onto the stack. And to delete them, I add 16 to remove 4 arguments off the stack. So it's just finishing calling every. Really not that important, but something that we added for completeness. One more question. That's a great question. Why does the position of EBP not matter once you open a shell? I mean, it depends on what your shellcode is doing. But if your shellcode never references this value, then it doesn't really matter what you put in there. Because if you think about it, EBP is just a register. It's just some register. It holds a value. And if you need it, you ask EBP for its value. But at this point, because you're executing code that you wrote yourself, if the code that you wrote yourself never asks EBP for its opinions, then it doesn't really matter what goes in EBP. And really, if you care about what's in EBP, you could even have your own shellcode inject some value that you care about back into EBP, if you really cared. But it's just a register. It holds a value. And if your shellcode doesn't use it, then nothing bad happens. That's a good question, though. OK, one more.
Does it matter where you put the fake RIP in main?
Yeah, there was a question of, does it matter where you put the fake RIP in main? Also a good question. You're stumping me with all these good questions today. So you're right. There's actually other ways to make this exploit work, too. Just like how in the original buffer overflow, the very first one that we showed you, you could put shellcode and the address of shellcode kind of in all sorts of different locations, below the RIP, above the RIP. You could put this pair of values, the fake SFP and the fake RIP. You could put it down here. You could put it like up here. You could put it up here. As long as it's somewhere you can overwrite, it's totally fine. Any other ones? Are you just stalling so that we don't get to the next topic? OK. OK, it is a tricky exploit, and we'll take a little bit of looking at. So don't worry if it doesn't make all the sense right away. Oh, did you have one more question? OK.
Yeah, I was just wondering because I guess like are the memory addresses always going to be like deterministic every time we run a program? Because with the project I was noticing that like addresses never change. Is that because of like virtual page tables?
Yeah, that's a great question about why these addresses don't change. If you stick around for like one more week, you'll get the answer to that. So stay tuned. It's a good question, though. For now, we're assuming they're the same. If you stick around for a week, we'll switch them up.